Welcome back everyone to Wes Explains Best. Today we're going to be doing a Kuta software worksheet, and this is going to be our tutorial on factoring with the greatest common factor. This is really an introduction to factoring trinomials. You really need to understand this before proceeding to something a little bit more advanced. So we'll go ahead and get started. What we're going to do here is factoring is essentially going in reverse of the distributive property. So let me go ahead and demonstrate the distributive property. So if we had something like 2x and then x plus 3 in parentheses, the distributive property, we would multiply what's outside the parentheses by what's inside. So we do 2x times x, that would give us 2x squared, plus 2 times 3 would give us 6, and then we just have the x, and this would be our simplified form of distributing. Factoring, so this is distributing. Factoring is when you go in reverse. You have it in what's called standard form, and you want to put it into this form, which is called factored form. Anytime you hear factored form, you need to think parentheses. So this is factored form, and this is standard form. Okay, now what's the trick in going in reverse? Well, if we're distributing something to both terms inside, this is the end result. That means that 2x is a common factor to both 2x squared and to 6x. How does that help us? Well, what we do is when we go in reverse, we need to look at common factors between the two terms. Well, in this case, two terms. There's probably going to be more. Yep, there's going to be more polynomials with more than two terms later on. Okay, so now we think to ourselves, what do 8 and 6x to the fourth have in common with each other? Well, if we think of some factors of 8, we know that there's 2, we know there's 4, we know there's 8. We don't usually include 1 because if you factor out a 1, it doesn't change. So 2, 4, and 8. Now what about 6x to the fourth? Well, we have 2, 3, 6, and then x to the second, x to the third, x to the fourth. So I'll just go ahead and put x there because we're going to know that this, I'll put x dot dot dot. Okay, so if we're looking here, we obviously identify that only, whoops, that's a little too big, only the 2 is a common factor between both of these. So that's the only thing we can factor out. So we're going to put a 2. That's our first step. Find the greatest common factor. Let me write a 1. So number 1 is find GCF. Okay, second step is we're going to put our parentheses. And what we're going to do is we're going to take the two terms that we started with, or the terms we started with, and we are going to, number 2, divide terms by GCF. Okay, so we've find the GCF, we put that on the outside, then we're going to divide the terms by the GCF. So this goes outside, this goes inside. So what happens when we do 8 divided by 2? Well, we get, let me write this in green, I suppose, 4. What happens when we divide 6x to the fourth divided by 2? We get 3x to the fourth, and then this is our final answer. So it's really just a two-step process. I was really hoping to get a 3 in there, but 2 steps is better than 3, I suppose. So that's our answer. We get 2 times quantity, 4 plus 3x to the fourth. Let's do another one that's a little bit more challenging. Okay, let's look at number 6. This one just stood out to me a little bit. Now, first thing we're doing is we're going to look at 5r and 4r to the fourth, and we're going to look for common factors. So we can start by listing them if we want. We have 5 is the only factor, 5 and 1, and we're going to write r. That's it. There's not much there. Here we have 2, 4, and we have r, and then I'm just going to write r dot 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 because you can see that we can go all the way up to r to the fourth power. So what is our common factor? It looks like our only common factor is the r. So what does that mean? That means we can factor out an r. So we're going to write an r outside. This is step 1. That's our GCF. GCF, greatest common factor, the biggest factor that they have in common. And now we're going to write everything else on the inside. Okay, so we do 5r. Essentially, we're doing this. We're doing 5r divided by r plus 4r to the fourth divided by r. Because when we distribute this r, we want the r's to cancel and it go back to standard form because we're trying to put it in factor form, but we're going in reverse. So we do 5r divided by r. That gives us 5. And then we do 4r to the 4th divided by r, and that gives us 4r cubed. And this is going to be our final answer. Another way to think of it is once you put your r on the outside, you think to yourself, this is how I do it. I think to myself, okay, I need to multiply r times what to give me 5r. And then I say, I need to multiply r times, I copy the plus sign if it's plus or minus if it's minus. I need to multiply r times what to give me 4r to the 4th. And as you can see, r times 5 will give you 5r. Oops, let me do that in green. R times 5 gives me 5r, and then r times 4r cubed will give you 4r to the 4th power. Let's move on to a trinomial. Looks like number 11 will be a good challenge. Okay, so now we have 3 terms. We're going to do the same process. Now, if you want, you can write the factors up here for each one. Make sure you include the negative in front of the 60, 50, and cubed. Okay, if you want, you can list all the factors. But once you do this enough times, you should see that there are obvious factors. So I'm going to go ahead and put my parentheses. And I know that each one of these numbers is divisible. I'm looking at the coefficients first. Okay, so the coefficients, we see that we have 10 as a common factor. 10 goes into 60, 10 goes into 60, or negative 60, 10 goes into 50. So what I'm going to do is I'm first just going to, well, I can just proceed from here because this does not have an n. If this term does not have an n, then that means we can't factor out a variable. If it was just these two, let me go ahead and show what that looks like. If it was just these two terms, if it was just those two terms, we could factor out what? What would be the common factor for the variables here? We could factor not only a 10, but we could factor out an n squared, because n squared is a factor of n squared, and n squared is a factor of n cubed. We do n squared times n to the first to get n cubed. So n squared would also be a factor there. In this case, that's not true because there's no n here, so we can't factor out a variable. I always like looking at number 1 for factoring. Number 1, I look at my coefficients. That's the numbers. And then number 2, I look at my variables. Okay, that's kind of the progression that I use. Okay, so now I'm just going to say negative 60 divided by 10. That gives me negative 6. Plus 60n squared divided by 10, 6n squared. And then we get 5n cubed. Really, you should write this in standard form. Standard form is when you have descending order. So I'm just going to go ahead and rearrange that so you see what that looks like. Your teacher may ask for that specifically. And there we go. Okay, we need to have a tougher example here so you can understand. 17 would be perfect. Okay, so number 17, we have a lot going on. The first thing I'm going to do is I'm going to look at all the numerical coefficients. Okay, so the numerical coefficients, what is a common factor between these three? Well, I have a negative 24, 36, 60. I know 3 is going to be a common factor to all of them. Is there something bigger than 3? I think 6 goes into all of them. Is there anything bigger than 6? I don't think 8. 12. 12 is a factor of all of them. I don't think anything bigger than that. Definitely not 24. 18 is not. Okay, so we're going to roll with 12. 12 is going to be our common factor, so we're going to put this outside the parentheses. Okay, see how I left some room? That's because I know I'm going to be handling the variables next. So now I'm looking at my variables. Are there any common factors with the variables? Okay, so you see that there's a squared and a b squared here. There's an a and a b here. This one only has an a. Because this one does not have a b, the b is missing, you cannot use b as your common factor. So we're going to forget about b. But since there's an a in each one, we can factor out an a. So we're going to go ahead and do that. We're going to factor out an a, and we're done. This is our GCF. GCF, greatest common factor. Now we're going to take each one of these and we're going to divide it by the GCF. So we say negative 24 a squared b squared divided by 12a. That gives us, I guess I'll write it in orange, negative 2, because I did the negative 24 times 12. The a squared cancels with the one of a's, we're left with a, and then b squared doesn't cancel with anything. I copy the plus because it's plus here. Now I do 36, ugly 3 there, sorry, divided by 12a. 36 divided by 12 gives me 3. The a's will cancel completely. Just show that here. Hold on. 2, 3 cancels. The a's cancel completely, and we're going to be left with a b. Copy the minus because it's minus here. 60 divided by 12 gives me 5. And then I factor out an a, so if I do negative 60 over 12a, again, I said that gives me 5. I forgot the a. The a's will cancel also, so we're just left with negative 5. Check to see if it's written in standard form, descending order. It is, and this will be our final answer. I don't want to do any more than this. I want to keep this video short, but I hope you guys found this helpful. And leave a comment if you need more of these problems done. I hope to see you next time on Wes Explains Best. Take care.